I love this question. This used to be on one of the old SAT practice tests, so I would teach it a lot. And I like it because it is a great way of showing how good you can be at the SAT if you are really confident in the SAT strategies, okay? So the way I'm gonna solve this is a little weird, but it's because I'm super confident with the strategies that I'm able to solve this very confidently overall. So let's take a look. The volume of right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height of cylinder A? So the red flag here is they're asking me to change the dimensions of something, but at no point did they give me the dimensions. So this is something that comes up in geometry a lot in the SAT, but pretty much any math topic where they ask you to change something, but they didn't give you the something to change. That's a big sign that we're probably going to arithmetize. We are going to make up a number because I don't want to change a concept of a dimension. I want to change a dimension, right? I want to change a number. That's easy. I can double something, right? Twice the radius. If I have the radius and I double it, that's easy. If it's a number like 1 or 7 or 19, I can double that. But it's just some concept of a radius, that's really weird. So I don't want to do that. So what I am going to do is I'm going to arithmetize. But like most cases where we arithmetize, there's going to be some sort of rule we need to follow. So first things first, let's just think of this as a plug points into equations, right? We have the volume of right circular cylinder A is 22 cubic centimeters. So the volume of a cylinder is pi r squared h. That is in the reference formula if you don't have that memorized, but there you go. So 22 is equal to pi r squared h. And let's just be really clear, this is for cylinder A. So they're asking me to change the radius and the height. I don't have a radius or a height. And generally speaking, when you have an equation and you have 2 missing pieces, that's not good. If we have 1 missing piece, that's great, because then we can solve for whatever's missing. We have 2 here, the radius and the height. So what I'm going to do is I'm going to think ahead a little bit. I want to have a number that is going to be very easy for me to take half of, right? Half of the height. Now, doubling something is really easy, but taking half of something, that's a little harder. So lots of ways I can go here, but I see the best case scenario is that I can think of the radius. How do I want to write this? I want to make up the radius as 1, and I want to use the height as 22. That way, when I get to cylinder B later, I have a radius that's doubles, that's 2, and a height that I can half very easily, so that's 11, right? So these are easy dimensions to change. And then let's see that it almost works out, right? So if I do 22 equals pi times 1 squared times 22, we see that this kind of works nicely, that we get the volume that we want. So that's the rule that I need to make sure I'm following. With one exception, right? 1 squared is 1. 1 times 22 is 22. But 22 times pi is 22 pi, right? Not 22, 22 pi. So those are different numbers, right? Pi is not like centimeters. It's not a unit. It is a number. So 22 and 22 pi technically are not the same number, right? So what gives? How? This doesn't make sense. Basically, I picked bad numbers in a way. But this is where confidence in the strategy really, really helps me, because I don't care about pi, right? Because when I take this same formula and I use it for the cylinder B, pi is pi, right? Pi doesn't change. So the radius changes, the height changes. I'm just going to kind of pretend that pi isn't there because it's all multiplication. So it's not really affecting things to divide it out. And so it's not changing. Pi is still 3.1415, blah, 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 no matter what cylinder I'm dealing with. So because I'm confident that I want numbers that I can see the change happen, I also know that numbers that don't change aren't really going to affect me here. If there was addition and subtraction somewhere in this, that might mean I can't get rid of that pi that easily. But this is just me being very confident in my math knowledge and my math ability and the strategies. I'm just going to completely disregard the pi. It's in both formulas. It's the same thing in both formulas. Let's get rid of it. Now I have a radius and a height that in cylinder A give me the volume that I want. And then I can change that radius and that height to think about what's going to happen for cylinder B. So that's going to be a radius of 2, so 2 squared, and a height of 11. So that is 4 times 11. So that is a volume of 44. And that is the answer. Done. I would have done this much faster than I did it for you, because to me, that move of getting rid of the pi is really obvious and I'm very confident that that is a safe move. But I wanted to make sure I didn't rush into that with you. And the arithmetize is also something that I would have jumped into right away, because like I said, we have a big red flag at the end of this question. Anytime the SAT is asking you to change something, but they do not give you the something, you should be nervous about that. That is how they set up some of their best traps. In fact, many of you are going to pick something like B here because you think about the change without actually seeing it. You think, oh, well, if I double the radius and take half the height, well, 1's times 2, 1's divided by 2, cancels out. No difference, no change. But it's not how it works, because we got a squared right there in the formula, okay? There's a difference. And yes, you can solve this without doing the arithmetize, but that's what the College Board's going to say. You want that stupid basic explanation, go to the College Board. My solution here is this very interesting arithmetize. I love using arithmetize on geometry questions when they just kind of vaguely talk about a shape, ask me to change it. I want to have dimensions. Geometry is best when I have actual measurements. Sometimes I got to make them up, but I'm very comfortable with that, and you should get comfortable with that too.